What's up, guys? We're doing question number 9, and let's get right into it. All right, guys, so I want to start question number 9 off with a quick disclaimer, okay? This is probably, I'd say, the most conceptually tricky problem that I've solved thus far for this GRE playlist. And I actually checked the statistics on how many people got this question correct, and it looks like only 30% of test takers got this question correct, all right, guys? And you have to keep in mind that the GRE, the people who are taking the exam, these are all people who are, potentially going into graduate school, right? So if only 30% of, potential graduate students got this question correct, that's pretty low, okay? So just always keep these things in mind, right? If you have a question that's kind of tricky, all right? Now, I'm not saying it's impossible. It's by no means impossible, but just something to keep in mind, all right? So don't get, discouraged by this one, all right? So let's get right into it. N is an integer greater than 0. All right, so that's interesting. Then we have quantity A is the number of different prime factors of 9n, and quantity B is the number of different prime factors of 8n. All right, so guys, let's just do a little refresher. All right, remember, a prime number is any number whose factor is 1 and itself. All right, guys, so an example of this would be 17, right? 17 is not divisible by anything other than 17 and 1, right? So itself and 1, okay? All right, guys, so that means that a prime factor is just going to be a factor that only has 1 and itself as factors, right? All right, so what I'm going to do here is let me just walk you through step by step how we should reason through this problem, okay? All right, so let's start with 9n, okay? So we have 9 times n, all right? But first, let's just start with 9, okay? So what are the prime factors of 9, okay? So for 1, we have 9 times 1, right? Or hang on, I'm sorry, hang on. Let me break this down a little bit nicer, okay? So 9, right? We have 9 and 1, and then we have 3 and 3, okay? So 1 is a prime number, and 3 is also a prime number, okay? So remember, it says the number of different prime factors, okay? So for 9, we only have 2, right? So 2 prime factors, all right? Now let's try 8 times n, right? And let's start with 8. So 8 is just 4 times 2, right? And then 4 is 2 times 2, right? Okay. So what that means is that 8 only has 1 prime factor, right? Or I should say 1 unique prime factor, right? And it is going to be 2, all right? So right off the bat here, we have that this whole thing, right? 9 has 2. Oh, I'm sorry, hang on. I was like, why did I put a 1 there initially? Yeah, so it just has 1 prime factor, right? Okay. So right off the bat, 9 has more prime factors, or more different prime factors than 8 does, right? Okay. So here's the thing, all right? What is n? We don't know, all right? So here's the thing. N could have some number of prime factors that are not different than 2, 1, or 3, all right, guys? So, and again, I'm trying to think of how I should how to explain this, all right? Let me just try an example, okay? Let's say that n was equal to 10, all right? So what we would have, and I'm just going to go ahead and erase this, okay? Just erase this part right here. All right, guys. Okay, so if n was 10, we'd have 9 times 10, right? And remember, since this is multiplication, we can just break these things down, right? So again, 9 is only going to have two prime factors, right? But what are they? It's 3 and 1, right? Okay. So what are the prime factors of 10? Well, the prime factors of 10, it's going to be 5 and 2, okay? So now, for 9n, we have 1, 2, 3, 4 unique prime factors. I'm going to call it PF, right? 4 unique prime factors, okay? But for 8n, let's see what that's going to be. So it's going to be 8 times 10, right? And we know that 8 is just, it's 2 times 2 times 2, so it only has, it has 2 as a prime factor, right? And 10 is going to be 5 and 2, right? Okay, so what that means is that we only have 2 unique prime factors. It's 2 and 5, right? So we only have 2 unique PFs, right? Okay, so what that means is that in this case, even though n, right, n only has 2 prime factors, we need different or unique prime factors, okay? So what that means is that these, in this case, quantity A would be greater, right? And here's the thing. We could make n a different value such that 3 or 1 is included in n, but it's not included in this 8n, so that we would get more unique prime factors for 8n than 9n. Okay, guys? So it's a little confusing, but basically we just don't have enough information, all right? Now, if it was just the number of prime factors, then it would always be equal, right? Just because, you know, or I'm sorry, excuse me, it wouldn't always be equal. Quantity A would always have more because 9 always has more, right? But again, it's different, right? It's unique prime factors, so it's a little tricky. All right, guys, this one was a little bit tricky. I'm gonna be honest with you, okay? If you have any questions, feel free to post them in the comments, and yeah, I'll catch you in the next video, all right?